Good morning, girls. So yesterday you were using your notes copy and just taking down basic notes from sets that you would have learned last year. You've taken this into your notes copy. We looked at equal sets, the union and intersection of sets. We also looked at subsets, the universal set, complement, cardinal number. Okay, so that's where we finished off on yesterday. I have taken kind of screenshots of those notes and they're on Teams. The only thing I didn't really go through with you is number 8. Okay, and I'm going to talk about that now simply because it's something that can be tricky to those of you that aren't used to notation. And it's just a matter of getting used to notation in order to be able to do this. So the generating rules of sets. When the number of elements in a set is small, we usually list the elements because, if you even look at a question 1 over here, A, listing set A is small. There's only kind of 1, 2, 3, 4, 5. There's only 6 numbers in it, so it's very easy to list it. But when you have quite a vast amount of elements, it's not really feasible to list everything just because there is so many numbers. Like if you were listing all of the natural numbers, that number is infinite and you couldn't possibly list all of those numbers. So there's kind of a strategy in coming up with how to list them easily. So the rule needed to generate a large set is when you want to kind of continue on something without actually continuing it on, you use 3 dots to do this. Okay, dot, dot, dot. And that kind of shows that goes on in one direction. Well, we can use 3 dots to help us explain that the numbers continue on without having to actually list them. Okay, so an example is A is the elements. So X, the values for the set go between -8 is less than or equal to the values, which is less than or equal to 8. What that means is the elements, which are X, the numbers that you don't know, go between -8 and 8. And as you would have seen last year, and even sometimes this year, is an element, the numbers are elements of Z, which are integers. That means that the numbers can be positive or negative whole numbers. And there are numbers that are ranging from -8 to +8. Now, you know yourself, there's about 16 numbers there. And sometimes it's not feasible to list all the numbers. So we know we're starting at -8 and we know we're finishing at 8, but we don't want to list all the numbers. So to start it off, chain brackets. Obviously you're starting off at -8. So -8, -7, -6. And you know this is going to continue on -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, and 8. And there's a lot of numbers there to show that you're going to skip a few numbers. So let's say you've done maybe 3 or 4 numbers and you know there's going to be about 16 of these. You can skip a few by doing dot, dot, dot. And pick up wherever you like. They did this symmetrically. What I mean by that is they did 4, they skipped a few and did another 4. So they did half of the elements. So if you just do a dot, dot, dot in the center, you don't have to list everything. They know that it's going to continue on. Number B. And again, I'm just getting you used to the notation of this. The numbers in the set of B, so X, the numbers that we don't know yet, go from 1 less than or equal to X less than or equal to 25. So B are the numbers from 1 to 25 inclusive. And they are elements of integers, which are positive and negative whole numbers. So they're the numbers between 1 and 25 that are whole numbers, and they include 1 and 25 because of that equal sign underneath. So B, instead of listing out all 25 numbers, what they've done is they've written 4, they've skipped a few by doing a dot, 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 and then they wrote the last 4. Okay, and that's all it is. So we're just getting used to the notation with this, and also that you don't have to write out all of the numbers if there is a lot of them. Note A intersection B. So the numbers that correlate with both sets are obviously the numbers. So this is going from positive to negative up to 8. And this is going from 1 up to 25. So the numbers that are the same for both sets are essentially 1, 2, 3, 4, 5, 6, 7, and 8 because they will be on both lines. Now, if you can't see that, what you could do is write down all of the numbers and you'd be able to see visually that the intersection is 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, sorry, 6, 7, and 8. Stop. Example C is 2x plus 1. Now that is an equation that you would have seen in algebra. And that means that the numbers go from -3 to 2, but you have to apply this logic. So the number is -3 first. So 2 times -3 is -6 plus 1 is -5. Okay, so hold on, yeah, -6 plus 1 is -5. So basically, this is slightly off. That should be -5 is your first one. Then -2 times 2 is -4 plus 1 is -3. Oh, sorry, it didn't include it. Okay, so we're not starting with -3, we're starting with -2. -2 times 2 is -4 plus 1 is -3. So that's where that -3 comes from. So that's -2 account for it. -1. -1 times 2 is -2 plus 1 is -1. So that's where that -1 comes from. Then there's 0. 0 times 2 is nothing. Plus 1 is just plus 1. That's where that plus 1 comes from. And then finally, the last number to account from, because we're not including 2, is 1. 1 times 2 is 2, plus 1 is 3. And that's where the terms come from. So when there's an equation involved, you have to use the numbers, multiply it by the equation to get your set. I know there's a lot in that. Going back to the dots. So if you have a large amount of numbers and you can't write all of them down, you show it with dots, dot, dot, dot. A set of natural numbers. So natural numbers are positive whole numbers that don't include 0. So the first one will be 1, then 2, then 3, then 4. But we know there is an infinite number of positive whole numbers. You can go into the millions, the trillions, and so on. So obviously you're going to maybe list 4 or 5 of them and then stop. But to show that they continue, you do a comma and dot, 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 because those numbers continue on. Likewise for the set of integers. Well, integers go back in the negative direction to infinity, and they go to the positive direction in infinity. So like -3 isn't the first integer. You could have -4, -5, -6, -7, -8, -9, -10, and so on. So what they've done is they've showed dot, 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 because those numbers continue on to the left-hand side. Then -3, -2, -1, 0, 1, 2, 3. And then obviously it's continuing on to the right-hand side, 4, 5, 6, 7, 8. And again, they've shown a dot, dot, dot. Rational numbers are fractions. So to show this in notation or in letters, what they've shown is Q, which is rational numbers. They've written a fraction A over B, where A and B are elements of Z. That means positive or negative whole numbers, not including 0. Because if you have 0 in a fraction, it's 0. Okay, it's not a fraction then. And then finally, the set of real numbers is denoted by the letter R. This is something you've seen before. I'm going to do example 1 and example 2. So I'll be implementing the notation in example 2, but for the moment I'm going to work on a problem with you and how you actually approach doing it. So in a class of 30 pupils, 17 of them study German, 16 of them study Spanish, and 17 study German, 16 study Spanish, and 5 study both German and Spanish. Represent the information on a Venn diagram. Use the Venn diagram to write down the number of pupils who study German only, Spanish only, or neither German nor Spanish. And just on my sheet directly underneath, I'm going through the example on page 40, and it's example 1 I'm looking at. So we know there's a class of 30 pupils. So the union, or the universal set, is equal to 30, and you should write that on your page. Because it's a class of students that might study German and Spanish and mightn't do the subject at all, you have to use the universal set. You draw both Venn diagrams, they're the 2 circles, and instead of writing German, you can abbreviate it to G, and you can abbreviate Spanish to S. You don't necessarily have to, but what you could do in brackets here is tell me how many students are in German, and there's 17. You could then go in and tell me how many are in Spanish, and there are 16. I have written down the information that they've given me in the question. So there's union, the universal set is 30. There's 30 people in the class, 17 of them do German, 16 of them do Spanish, and there is a number of students that do both. So the intersection, German intersecting Spanish, is 5. But I also need to find out how many do neither, because that's one of the questions. So that's German Union Spanish complement. So when you take out the German and Spanish together, what are we left with on the outside? They're the students that do neither. And I've given myself space to do the calculations. So I can't really do any of this information. The first piece of information I need to account for is the students that do both. Because when you list numbers, as you would have seen yesterday, you list them once. You can't say the students are there twice because it can only be 30 students in the class. But 5 students study both, so that's the most important thing. There's 5 students that do both. Now, if there's 17, and I've accounted for that, so tick it off. There is 17 that study German, but I've already 5 people in the class. So take out the 5 because you already have those students in the German class already. So take them out and there is 12 left. What that means is there's 12 students that just study German. There's 5 students in the class that study German and Spanish, but the 12 and 5 make the 17. So I have 17 accounted for, and I have my calculation beside it. Now we'll do Spanish the same way. 16 people do Spanish, but I've already accounted for 5 people already in that class. So I can't count them twice, so take out the 5 that are already there, and that makes 11. So there's 11 students that just study Spanish. So I've accounted for that. So I was told 4 pieces of information. Those that studied both and those that studied each individual subject. And lastly, I was told how many people are in the class. Well, to figure out how many students do none of those subjects, we need to add up the students and account for the 30 pupils in total. So there's 30 people in the class. Take away the 12 and the 5 and the 11. Okay, so I need to take away all those people. 12 and 5 is 17. 17 and 11 is 28. So there's 30 people in the class. There's 28 people accounted for. Okay, so we've got the attendance on the 28 of them. There's 2 people left. And those 2 people mustn't study any of those subjects. So if they don't, but they're in the class, put them on the outside of the 2 circles, and that is the question done. Now we have to answer the questions. And I'm going to use notation in this just to help you along with it. So German only. In notation, that would be the cardinal number of Spanish complement. So German only, I was talking about that 12, but it could be written as the cardinal number of Spanish complement. Complement means take it out or cover everything in Spanish. German only is 12. If they do Spanish only, that means it's the cardinal number of German complement. So take out the German complement and there are 11 students left. Now, the students that do neither Spanish nor German, these are the students that don't study any of those subjects. So it's the cardinal number of German Spanish complement. German together with Spanish complement means take out all of that, and what you're left with is 2 students. There are 2 students in the whole class that don't do any of those. Okay. That is how you approach any sets question. You pick out the information you definitely know to be true, and that's the intersection, or if you were told it, the number of students that do neither. Work with that information first and then start working on each individual Venn diagram, and then work back up to the total amount of students, and you'll have used all of the pieces of information. I just added information to this to get you used to seeing notation. We are now going to work on example 2. In your book, on page 40, this is an example that uses the notation that I was talking about in Rule 8. And it's really important that we were able to see that, so I did that a couple of minutes ago. I need to find a set of A intersection B intersection C. What that really means is, if you have 3 Venn diagrams intersecting A, B, and C, you're looking for the bit in the middle of the numbers that intersect all 3 sets. That's what you're looking for in the diagram. Okay, so you have 3 different Venn diagrams, and it's the intersection of A, intersection B, intersection C. So where the 3 of them cross over, that little bit in the middle. And we're given 3 pieces of information about the 3 sets to help us solve this. So it tells me A are the numbers between -3 and less than or equal to 12 that are integers. So the numbers, it doesn't include -3 because there's no line underneath it. So the number you're starting off with here is -2. And it's all the numbers going all the way up to 12. So -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. It's showing dots in the middle to show that you're skipping a number of numbers. So what I've written on my sheet is basically what we were told. We're told that numbers go from -3 and don't include it, all the way up to 12 and does include it. So A is -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that's what A is. B is all the elements that go from 2 less than x less than 9. So it doesn't include 2 and it doesn't include 9, but they're natural numbers between 2 and 9. So the first one, it doesn't include 2, so the next one is 3, 4, 5, 6, 7, 8, and that's it. Okay, so 3, 4, 5, 6, 7, 8. That's what B is. And C is 2 times the numbers. Okay, so it says 2x, so you have to double all of the numbers once you calculate which ones you need to include. The numbers between -4, and it includes it, between 10. So it's not -4, it's double -4, which is -8, -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. Sorry, it's not. It's every second one. Apologies. -8. I'm going to start that again. So if I double -4, I get -8. Then if I double -3, I get -6. It's every second one. Apologies. If I double -2, I get -4. If I double -1, I get -2. If I double 0, I just get 0. Then it will be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Apologies about that. So it's not every single number, it's every second number. It's then asking me what numbers are common between all 3. So get a highlighter. When you have the list fully written out, obviously it makes this a little bit easier. So pick the one that has the smallest amount of numbers to work off of, which is B. So in B, there are the numbers 3, 4, 5, 6, 7, and 8. So because B has the smallest amount of numbers, that's the constraints that we're working towards. There are no negative numbers in B. The negative or the numbers start at 3. Now, let's look at C now and see which ones we can account for. We can see that the negative numbers are excluded and we're starting in the positive numbers and they're all even numbers. So that means I can only work with the even numbers here, which means 3 isn't on the bottom line and 3 is on the top line, but it's not everywhere. So we can't include 3, but 4 is there. 4 is on all 3 lines. So 4 is an intersection. Okay, 5 is there and there, but it's not on the bottom line, so we can't use 5. 6 is there, there, and there. So 6 is on the intersection. 7 is on the top 2 lines, but it's not on C, so we can't use it, but 8 is. So when it comes to seeing the intersection between 3 lines, always use the shortest one or the one with the least amount of numbers, because that's the constraints. There's no negative numbers, okay? And then when you start to look at them, use 2 lines first to help you guide yourself. And then use the last line then to correlate all of the information. So the question was, find the set of A intersection B intersection C. So A intersection B intersection C are the numbers 4, 6, and 8, because those 3 numbers are on all 3 lines. 4, 6, and 8. Now that we have seen that, okay, and we've looked at it, the examples are in your book, but they don't go through each of the numbers, and sometimes it's a little bit easier when you have all of the numbers to actually solve it. We are going to do some classwork. So we've looked at the notation from your book on page 40, we've looked at the 2 examples on your book on page 40, and we've seen that you can use 3 dots in order to not write down all of the numbers, but sometimes there's a benefit to actually writing them down because you can see the numbers a little bit clearer. Today in class, you're going to go to page 41. And in class, we are going to concentrate on a couple of questions. We're going to do question 1, 2, 3, and 5. 1, 2, 3, and 5. And when you're finished that, you're finished the class. But you are going to start that obviously now, but you're going to join me live for attendance and any questions that you have on these questions. So whilst you're starting them and you run into, or if you run into difficulty, I can help you correct them. Okay, see you live.